Namaskar friends, I welcome you all in the class of structural analysis. Friends, you know the civil engineering structures. In civil engineering, before designing a structure, it has to be analyzed, and we do certain idealization and simplification for analysis of the structure. So today we will start what are the type of civil engineering structures, how do we classify it, how do we check the stability of the structure, and how do we find out the static indeterminacy of the structure. It means that if it is a determinate structure, whether we can analyze the structure by simply writing the equations of equilibrium or not. So let us start first with the classification of the structure. Friends, as you know, any classification is done as per our convenience, for what purpose we are going to classify any structure. So naturally in civil engineering we have to analyze a structure, so we have to see that how the structure we take the assumption, or what type the structure we classify, so that we can analyze it easily. So mainly there are two types of structure. One is called a skeletal or framed structure, and the other one is continuum or surface structure. There is a lot of difference in the analysis of these two types of structures. Now, so far as we are concerned, in this BTech program, we will be dealing with the skeletal or frame type of structure. Now, if you again classify it, there are pin jointed structures, and rigid jointed structures. In both the types, you may have two-dimensional plane structures or three-dimensional space structures. In continuum or surface type of structures, we have plates, shells, and membranes. Again, in plates you may have folded plates or plain plate like structure. So you know, we in this course, as I stated you earlier, we will be analyzing a skeletal or framed type of a structure. So let us see what is the characteristic of such type of a structure. How do we differentiate between a skeletal or frame type of a structure and other type of structures. I think you are aware in a skeletal type of, this is the type of structure. Nowadays most of the multi-story buildings are being made from such structures. These are called frame type of structures. If you want to look into the basic characteristics of such structures, the basic characteristic that its one dimension is prominent. What does it mean? It means that in comparison to the other dimension, say this is an element, a beam element, in which in comparison to its area of cross section, its length is prominent. So that is why we call it a skeletal or frame type of a structure. This cross section may be constant or it may be varying. So it can be prismatic. If its cross section is constant, we call it prismatic, or it can be non-prismatic. It can be straight or it can be curved. But the basic characteristic is that its one dimension is prominent. Again, the joints, as I said you, the joints may be of different types, prominently of two types. So accordingly we classify it. Joints play a very important role in civil engineering structures, because in a structure analysis, you see, depending on the joint, deformation will take place. So if any, say this is a frame and you are applying a load in this direction, since it is a rigid frames means that any cross section is there which is welded at this point and again welded at this point, so it can withstand this load. But suppose you put a pin joint here, here, here and here, what will happen? pin joint means it can rotate at these joints. So if you apply a load P in this direction, it will simply fall because it can rotate at these points. So it cannot withstand a load in this direction. So joints play a very important role in civil engineering structures. That is why we have classified it in two types of joints. One is pin joint and other is rigid joint. Now, how we denote it in our sketches? Pin joint is denoted by a small round circle. Say if these two elements jointed by a pin here, it will be shown like that. Then pin joint also may have other type of connections also. Suppose this pin joint is fixed here and a beam is to be attached. Again a small circle will come here to show that it is jointed by a pin. For this type of notation, even if it is like this, it shows a pin joint. If it is a triangular block and it is restrained at the bottom, so it means that it is a pin joint. Again, this shows a roller joint. Here it is a pin joint and it can move in this direction, so a roller support has been shown here. So it is a roller joint. So it can also move in this direction, whereas in this type of notation, this is a fixed end, but it can rotate in this direction. These two movements have been restrained, but this movement has not been restrained, as it can, here it is a pin joint, it can rotate. Similar is the case for this joint, but here it can move in this direction. In this direction the movement has been restrained, and again it can rotate in this plane. So in pin joint, rotation is allowed. Rotation is there. Whereas in rigid joint, how do we show a rigid joint? Say this is a column and it has been fixed here. We also call it fixed or rigid joint. It is also called fixed joint. So this is a fixed end, or this is a beam. Say here it is supported at a roller. So this is a fixed end. What does this do? This restrains all the type of movements in all the direction. So in a plane structure, you see in a plane structure there can be three types of movement. One is take it in vertical direction, say y direction. The other you can take in x direction, and there is a rotation if you taking anti-clockwise as positive rotation. So in a plane there could be three types of movement or displacement. These three types are displacement in x direction, displacement in y direction, and rotation say theta in anti-clockwise direction if you have chosen these as positive sign of direction. So in the case of a rigid joint, all the three types of movement is restraints. So neither it can move in this direction, neither it can move in this direction, or nor it can rotate in this direction. So all the three types of movement is restrained in the case of rigid joint. Now let us talk about some of the basic assumptions which we take for the analysis of a structure, elastic analysis of a structure. So these basic assumptions are: homogeneous or isotropic material, homogeneous and isotropic material. What is this assumption? This means that the material from which we design or from which we make any structural element, it should be homogeneous. It means that at every point of an element the same material should be there. That is meant by homogeneous. And isotropic means that in all the direction the material quality should be same. It means that if there is any element, say a beam is there, so whatever element is here, the same element should be there. Again, if its property should be same in all the direction, so that you take a point here, so whatever strength will be there in this direction, the same strength should be there in this direction also, in this direction also. So this is called the isotropic property. So this is the basic assumption with the whatever analytical methods we will learn. It doesn't mean that if a material is not isotropic, we cannot analyze it. There are certain other methods which we imply for the analysis of such structures. So presently in this course, whatever technique we are going to take up, the first assumption is that it should be homogeneous and isotropic. Then it should be, it should be elastic and linear. Again, this is very important assumption in which we assume that the material is elastic and its behavior is linear. Elastic means that if you apply a load to any structural element and then you remove it, after applying load you will have some deformation, but when you remove the load it will come back to its original position and there will not be any deformation after that. This means elastic. And the linear means that the stress strain curve should be straight line linear. It means that the deformation should take place linearly. It means that it should follow the Hooke's law. That if we increase the load proportionately, the deformation will take place in a linear fashion. Now, third assumption is superposition. It means that if you apply load, say on any structure, if you applied load P1 and a deformation of delta 1 takes place here, again you apply a load P2 here, and because of this further delta 2 deformation takes place, then it means that if you apply a load P1 plus P2, then the displacement should be, deformation should be delta 1 plus delta 2. It is irrespective of the order in which you apply the load. You may apply the load P2 first and then P1 afterwards, or you may apply both the loads together. The deformation will be same, delta 1 plus delta 2. So, this is the principle of superposition. And then again the one more assumption is there, that is unchanged geometry. It means that certain structure is there, and if you are applying loads on the structure, its overall geometry will not change. The deformation will take place. There may be certain deformation, but the angle, this angle will remain same. Again, this angle will also remain same. So, I think this figure, you can see, I will draw it again. If this is a structure and you apply a load here and it deforms in such a fashion that these angles are appreciably changed, we can see, then we can say that the geometry has appreciably changed. But this should not happen, then it is not in elastic limit. So, we are not going to deal with such a structure in our elastic analysis. So, this is not the analysis which are going to deal with. We are not going to deal such structures in this type of analysis. In this type of analysis, only small deformations will take place. So, so that these angles, they are unchanged, and these deflections are also very less as compared to the length or the prominent dimension of the structure. So these deformations or deflections are very less in comparison to the prominent dimension, and the overall geometry does not change. So this is again the basic assumption that the geometry will remain unchanged. Now let us see the stability of structures. What do we understand by stability of a structure? It says that for any part of a structure, any part or whole structure, if there is a large deformation as compared to its dimensions, then the structure is not stable. It means that after applying load, there should not be any large deformation or displacement in any part or the entire structure. There should not be such a large deformation or displacement as compared to their dimensions. If such deformations are taking place, then the structure becomes unstable. So if you see in a plane, if you can see, if there is a structure, say there is a truss, a truss is there. So there are two types of stability. One is because of the external, one is called external stability, that is because of, suppose no restraining force is there from outside. So if you put any force in this direction or in this direction, the truss will move, the entire truss will move in these directions. So it says the external stability that the entire structure should not move or should not have large deformation after applying the loads. So to restrain such type of movements, we require at least 3 external forces. Why do we require 3 external forces? Suppose we put a roller support here, and again we put a roller support here. What will happen? This is not a roller support. We again put a roller support here. So what will happen if you put a force in this direction? The whole truss will move in this direction because there is no restraining force in this direction, whereas it can take loads in these directions, because in this vertical direction the roller support is there, so it can restrain its movement. So it is necessary to restrain it in x direction also. So suppose we have made it a pin jointed support. So now it is not a roller support, it is only a pin jointed support, and this is a roller support. So here two reactions will be there. One will be in the vertical direction, say RA, and other will be in the horizontal direction. Let us call it VA and HA. So now this horizontal reaction, it will stop its movement in the horizontal direction also. So suppose one can say that only if two restraints are there, why do we require this restraint? Suppose we remove it, what will happen? It can, you can see easily, because of these forces it can rotate in this direction. The entire truss will rotate in this direction because this is a pin joint, so it is free to rotate here, and these forces will create a moment about this point. So the whole truss will be rotated. So it has to be restrained here also, maybe in a single direction, either in this direction, vertical, or in horizontal direction, so that it can restrain it from rotation. So at least three external reactions are necessary for a plain pin jointed structure. Now again, merely applying a equation that if three external reactions are there, the structure may not be stable. So we will have to look into the structure physically also. Say, let us see this structure. Say a beam is here and we apply 3 roller support. Again the structure will not be stable because all the 3 reaction components are in same direction. So it cannot stop it in horizontal direction. It cannot stop its movement in horizontal direction. So it means that these reaction components should not be parallel. So there should be non-parallel reaction component should be there. Again, you see it is a truss member. And say you have a pin joint here and an external and a roller support here. Now I have made them tilted so that if Now let me draw it again. Let me make it more easier. Say this is a pin joint here at this point, and then we put a roller support in the horizontal direction. Then what will happen? You have this component, say VA, this is A, B, again this component VB, and then this is HA and this is HB. So what do you think? Will it be an stable structure? I don't think it will be stable, because again if you put a load here, it is going to rotate in this direction. Why? Because all these forces, all these reaction components are meeting at point A. This HB is also coming through point A, HA and VA, all the three reaction components, they are meeting at point A. So that if you put any force for which moment can be taken about point A, there will not be any restraining moment. If you take moment about A for this force, any force P, it will have some moment. And what about restraining moment? Because all these three reaction components, they are passing through point A, so they will not have any restraining moment. So they can't stop it from rotating. That is why the three reaction component should be non-parallel and non-concurrent. Again, one more thing I will like to point it out here, that as I said that these forces should be unstable, these forces should be non-parallel and non-concurrent. Suppose for any structure, say a beam is there and we make three supports which are non-parallel, it is slightly tilted, and these two are parallel. In the next session we will see that this may also create some problem. So the forces should not be trivial also for stability of any structure. So friends, in this session we have seen the classification of a structure and the stability of a structure, types of a structure we have discussed. In next session we will be discussing the statical determinacy of the structure. Thank you very much.